Alright, so in this video we're going to go over other exercises involving probability, however in this case involving decks of cards. Okay, so we have a standard deck of cards in which we have 52 total number of cards, and then we're going to look at probabilities of drawing each of the following. So the probability of drawing a queen. Okay, so in this case, let's define our event A, which is drawing a queen. Okay, and we are going to find the probability that the event A occurs, which is going to be, well, let me look for all the queens in this deck of cards right here, and I'm going to highlight them. So all the queens are right here. How many successes? In other words, how many total queens do we have? In this case, we have 4 out of 52, which in this case is 2, it can be reduced to 1 over 13. Okay. The probability of drawing a card with an even number. So let's define the event A, which is card with even number. Alright, so let's highlight all those outcomes in which we are going to have even numbers. So in this case, the 2s, the 4s, 6, 8, and 10. If we count all these successes, we are going to have that the probability that A occurs is 20 out of 52, which reduces to 5 out of 13. Now, let's see. The probability of drawing a black card with a number. Okay, we need to be careful here. So now we look at all the black cards that are in the first 2 rows. However, we only want those that have numbers. In this case, the cards from 2 to 10, the black cards from 2 to 10. Okay, so we are going to look for, let's find the probability that A is black card with numbers. So the probability of A will be the number of total successes, which is 18 out of 52, which equals to, and can be reduced to 9 over 26. Okay, let me count them all again. So 1, 2, 3, 4, 5, 6, 7, 8, 9 times 2. Yes, that's correct. 9 over 26. Now the question is, what is the probability of drawing a red king? Well, in the previous example, I didn't do it the intersection way. I'm going to do it the intersection way, for example. Okay, I'm going to call A to be red and B to be king. I could have done that here as well. I could have defined those events in the previous. Actually, I'm going to do it as soon as I'm done with this example right here. And in this case, it has to be red king. In other words, the probability of having a card that is red and also king at the same time. I mean, it's B, not K. So in this case, I'm going to highlight all red cards and all the kings, and I'm gonna look for the intersections only, because those are the cards that have both conditions, red and king. In this case, 2 out of 52, which is 1 out of 26. Okay, so in this case, let's say we define, I'm going to do it on the side. I'm going to use a different color. So let A be black card and B be a numbered card. So I'm going to highlight all the black cards this time. In this case, all of this. And I'm going to highlight all the cards that have a number with blue, and I'm going to count the intersections. Do you see all the intersections? It's the exact same amount of cards than the ones we did. So the probability of A and B happening at the same time, it's still going to be 18 out of 52, which is the same as 9 out of 26. Let's look at the next page to see what do we have. So the probability that a card drawn is an ace, a 2, or a 3. So I'm going to define 3 events in this case. I'm going to define the event. We'll use a different color this time. Okay, so how about gray? No, not gray. I'm going to use, I think it's green this time. Okay, so I'm going to have 3 different events. Letter A, event A to be an ace. Event B to have a 2. And letter C, event C to have a 3. So I'm going to highlight all the A's, all the aces. There's 1. I'm going to highlight all the 2's, and I'm going to highlight all the 3's. So in this case, if you look at these 3 events, these are disjoint events, or they are mutually exclusive events. So in this case, we are going to find the probability that either A or B or C, using the right notation here, we get the probability that A or B or C, which is going to be the sum of each individual probabilities. And all we do is going to be 4 out of 52. Probability of event B, it's going to be 4 out of 52. Probability of C, also 4 out of 52. If we add this together, we should get 4 times 3, that's 12 out of 52. Which reduces to 3 out of 13. Okay. Let's see, the probability that the card drawn is a diamond, a spade, or a club. Alright, so number 1, diamond. Let me use 4 diamonds, and then spade, and then club. Okay. So there are 3 events going on in this case. So event A, let's define event A as drawing a diamond. B, drawing a spade. And C, to drawing a club. So the probability that A or B or C will be the individual probabilities in this case. Because if you notice, these three events are disjoint. They don't have overlaps. We're going to get there to some of those soon, you'll see. I'll show you how that works. So this will be 13 plus 13. 13 out of 52 for the diamond because there are 13 diamonds. 13 out of 52 because there's 13 spades, and 13 out of 52 because there's 13 clubs. 13 times 3, that's 39, and reduces to actually 3/4. And you can see that from the picture, we are shading 3/4 of the entire picture. Probability of getting a card, a red card, or a queen. All right. So let A red card and let B event B be queen. So I'm gonna highlight all the red cards with orange and all the queens with blue. Okay, in this case, if you notice, there are overlaps, so these two events are not disjoint or are not mutually exclusive. So when we look for the probability for this, probability of A or B, in this case will be the sum of the individual probabilities, but in this case minus the overlaps, which in this case it's going to be 13. Well, not 13, it's going to be 26 red cards and 4 queens for our 52, but we are going to subtract the overlaps to avoid counting any duplicates, so we subtract 2 out of 52, which will give us a total of 28 over 52, which reduces to 7 out of 13. The last of this example is going to be a very interesting one. So we're going to have event A, B, and C. Let's define them first. So event A is to draw a 4. Event B is to draw a 5. And event C is to draw a spade. Alright, so let's highlight this. Okay, so let's highlight all the 4s. Let's highlight all the 5s. And let's highlight all the spades. Now, keep in mind that in this case we are going to have 2 different overlaps. Alright, we are going to define those very, very carefully. So we are going to look at the probability that the event A or B or C, which in this case as usual is the sum of the individual probabilities, but in this case I'm going to subtract. Okay, so let me highlight. A is orange, B is blue, and C is pink. So in this case, I'm going to subtract the overlap between the orange and the pink, which will be the intersection between A and C. All right, let me actually use a different color here. And then this is the one with the square. And in the other hand, I'm going to draw a triangle for the other overlap, so it's easy to identify where is that overlap coming from. P between, in this case, B, event B, and C. Okay. And where was the other color? I think it was here. This is the one. So it's time to put numbers. So the probability of getting a 4, we have 4 4s. We have 4 5s out of a 52 card. And we have 13 spades. Each of the overlaps will correspond to 1 for each. This will be reduced to 19 over 52, which is final answer. Okay, so this is the end of this additional examples. I'll see you in another video.